Calculation of axis ECG number 1. See the ECG carefully. Frontal lead you have to see. First, second, third, AVR, AVL, AVF. Those are enough to calculate the axis. Lead 1 is positive, 2 is positive, 3 is equivocal, means positive and negative deflections are the same. AVR predominantly negative, prominent S wave. AVL, AVF predominantly positive but small R wave comparatively to the one and lead AVR S wave. So now find out the most equivocal lead, but obvious it's lead 3 is most equivocal. So axis will be the perpendicular to lead 3. See the diagram, remember the diagram. Lead 3 is at plus 120. So perpendicular is AVR. AVR is perpendicular to lead 3. AVR is predominantly negative, but remember AVR negative is plus 30 and AVR deflection positive is minus 150. See the diagram. So the axis is plus 30. That's all. Calculation of axis in image 2. See all the images like lead 1, lead 2, lead 3 predominantly positive, AVR predominantly negative, AVL positive plus negative, so it is equivocal. AVF predominantly positive. So the most equivocal lead, as we already spoken, that lead AVL. So axis has to be perpendicular to lead AVL. Which is lead which is perpendicular to lead AVL? Lead 2. Lead 2 is at plus 60. So axis is around 60. If you are not wrong, somebody asks you, you say 60 is around 60. But you want to be very correct without just looking at ECG also, you want to be very correct. You see AVL. AVL is slightly more negative than positive. Now, if you see at 60, remember left lower quadrant lead 2. So, and AVL negative is right lower quadrant is around 150. So, that axis pointer will slightly move towards negative pole of the lead AVL. So AVL is at plus 170, plus 150 and lead 2 is at plus 60. So that pointer will move towards lead AVL. So it is around slightly, because it is very slightly more negative than positive. So around 70. So axis is around 70, which can be confirmed on the ECG. Okay, thanks. Calculation of QRS axis in image 3. Observe 6 leads. Lead 1 predominant positive, lead 2 predominant positive but has negativity, lead 3 predominant negative, lead AVR predominant negative, lead AVL predominant positive, lead AVF predominant negative. Now, actually speaking, there is no equivocal lead in this, but if you carefully observe, 2 is more close to equivocal out of these 6. So timing, consider 2 is equivocal. So which is a perpendicular lead to lead AVL, and so axis is toward the positive pole of the lead AVL because AVL is positive. Had it been negative, the axis would have been negative pole of the AVL. So now AVL positive is minus 30. So axis is minus 30. No, it is not minus 30 because lead 2 is not totally equivocal. It is more positive than negative. So that pointer needle from minus 30 will move towards plus 60 where the positive pole of lead 2 is situated. So it will move towards little bit towards the positive pole of lead 2. Now, so axis will be less than minus 30 and towards the lead 2. So it will be between 0 and minus 30. So between lead 1 and AVL. Axis between 0 and minus 30 is leftward. You can call leftward axis, but it is not left axis deviation. Left axis deviation when the axis goes beyond minus 30. So this is normal axis. Okay, thanks. QRS axis
Image 4. Observe all 6 frontal leads. Lead 1 predominant positive, lead 2 predominant negative, lead 3 predominant negative, AVR predominant negative, AVL predominant positive, AVF predominant negative. Now, what do you think? Which lead is equivocal out of these 6 lead? Pause and see. I think lead 2 as well as lead AVR both are equivocal. Anyone you take. In this case, I will take lead AVR as equivocal. Now, which is perpendicular lead to AVR? Lead 3. So, axis is directed toward lead 3. If lead 3 is positive predominantly, then axis is plus 120. If lead 3 is predominantly negative, the axis is minus 60. So, in this case, the axis is minus 60, which is left axis deviation. But if you observe AVR very carefully, negativity is more than positivity. So, AVR negative is at plus 30. So, the pointer which I told you of minus 60 will tilt toward AVR little bit, because AVR negativity is slightly more than positivity. So, it will be less than minus 60. So, the axis would be around minus 45 or to 50. That again is a left axis deviation. The cause of left axis deviation in this case is left anti-air hemiblock or left anti-air fascicular block. That's all. Thank you.
Calculation of QRS axis in image 5. See all frontal leads, lead 1, lead 2, lead 3, lead AVR, AVL, AVF. Lead 1 is predominantly negative, lead 2 is predominantly positive, lead 3 is also predominantly positive. Lead AVR looks equivocal, AVL predominantly negative, AVF is predominantly positive. Now AVR seems to be most equivocal. So the axis would be perpendicular to that lead, and lead 3 is perpendicular to the lead AVR. So lead 3 positive pole directed towards plus 120, that is right axis deviation. Commonest causes for right axis deviation is right ventricular hypertrophy, right ventricular dominance, lateral wall MI, left posterior MA block, chronic lung disease, acute call pulmonale, reverse arm electrode. So right arm lead is attached to left arm and left arm to right arm. And many times in children you see rightward axis, which is a normal variant. That's all. Thank you. Calculation of axis in image 6. Observe all 6 leads. Lead 1 predominantly negative, 2 and 3 are also predominantly negative. AVR is predominantly positive, AVL is predominantly positive, AVF is predominantly negative. Here we calculate by taking 2 perpendicular leads. Take lead 1 which is predominantly negative, take lead AVF predominantly negative. So lead 1 negative is towards 180 plus or minus 180, and lead AVF negative is towards minus 90. So axis is between minus 90 and 180. So it is in the right upper quadrant, that is extreme area, extreme axis deviation, or you also call it as a no man's land. One clue here is also predominant AVR positive, which is generally negative. So AVR positive is plus 150. So this is extreme axis deviation. Thank you. Determination of QRS axis in image 7. Observe all 6 frontal leads, pause and calculate the axis. If you see, all the 6 frontal leads shows equiphasic distance, means equal positive as well as negative reflection. So QRS axis cannot be determined in this ECG. So this QRS axis is called indeterminate QRS axis. Indeterminate QRS axis is when QRS complex is equiphasic in all limb leads and QRS axis cannot be truly determined. This situation is most commonly encountered when the QRS voltage in all limb leads are very low, as seen in severe hypothyroidism, cardiac tamponade and constrictive pericarditis. Thank you.